So the starting point, I think, really, when we're looking at DC motor angle control. Okay, and sorry if my camera's a little bit blurry, I need to have a look at that. So what we're going to do is start off with a system. So you all know the system consists of an actuator. So this is effectively your do, to change something. And then what we've also got here is the process. Okay, and here we have the output, and here I'm going to call it input for the time being, but you know that that's going to change based on what I said to you last week. So the actuator in this case, as you probably know, is the DC motor. Okay, and the process is going to be, we'll say, rotation of motor shaft. Okay, so in terms of the open loop system, the input to the DC motor, if you know anything about DC motors, there's going to be a voltage. So I'm going to supply it with a voltage, and that's going to then create the process, i.e. the rotation of the motor shaft. And then the output is going to be motor, we'll call it motor angle. Right, so that pretty much there is your open loop system. Does that make sense so far? Yeah. If there's any questions, I'll answer them at the end. So that's your open loop system. So ask yourself, if you were to supply a voltage to that DC motor, the shaft of the motor is going to spin, and what it's going to obviously do is continue to spin as long as you're supplying the voltage. Okay, true? So in the case of the question where it says, is it possible to control the angle without feedback control? My answer would be no, because obviously the input and the output are independent. So you're obviously supplying your voltage, and then you're getting the motor angle. You'd obviously have to time how long you held the voltage for, and it's probably very, very unreliable to do that, and probably not realistic that you're going to get the angle that you're after. So no, it wouldn't be. So what we introduce is feedback path, and here what we have is, as we called it last week, we have a measurement device. And in this case, what I'm going to tell you is the measurement device that we would use is an encoder. Right, and I'm going to give you a source to look after this where you can read up more into encoders, but obviously you can have a look in your own time. So what that there is the feedback path. What we've got is the measured, what we've got from the encoder, and there's going to be a little bit of processing the information of the data, but what we want is the measured angle. So what we have is the actual motor angle, the measured angle. There's obviously going to be some error slightly on this measured angle, because obviously in anything to do with engineering we get errors. Right, and then what we've got then is the summing junction. And just to remind you, what we use blocks for is to represent components, and we use lines and arrows to represent signals and direction of signals. And then summing junctions is to effectively subtract and add signals. So as you remember, this is our reference. This is effectively our desired outcome, or our requirement of the control system. So our requirement of the control system is desired angle of the motor. Okay, so desired angle of the motor. So as you remember from last week, desired reference, I'm just going to use the notation R, Y, and then here we've got the error, which notation we're going to use is E. Okay, and the error is effectively reference subtracted, subtract the measured angle. So that kind of makes sense if you think about it. Well, this is what I desire, this is what I'm measuring, the difference between those is my error. And the error signal is effectively used to control the to effectively action, or the control action. So here the control. Okay, so the control here. You're going to obviously become more aware of this as we go week by week, all the different components and how this all kind of works. So what we need in there, just remember, is a negative, because it's reference subtract the measured angle, hence that, and this here being your feedback loop. The thing that changes though now for your closed loop control system is, rather than having input, what we have is the control output. So we've gone from an open loop system to now a closed loop control system. Right, are there any questions regarding that? going to stop recording that.